Assalamualaikum and hi. Before we go to table and user interface production, I will explain first the overall process. We divide into three parts: requirement, problem statement, and research and problem solving. For the first one is requirements. We need to know what we need to do. We need to build MATLAB code to produce flow tables with Mach number below 5, and we need to create a platform for a user. But we face a few problems. The first problem is how we link each equation with each other in MATLAB, and how to produce table in MATLAB, and how to make each parameter as variable, and how to create interface for a user. After a few research made by us, we found a solution to this problem. To link equation with each other, we make Mach number as a variable. To produce table, we use range and display code in MATLAB, and to make each parameter as variable, each parameter is set as a function, and to create interface for a user, we use GUI.
I'm going to explain about how to create isentropic flow table in this MATLAB software. First, we need a requirement for this isentropic flow table, which is Mach number less than 5. M here is represent the Mach number that we use, which is from range 1 until 5. 0.2 here represent the increment for this isentropic flow table. So this is the equation in the coding form to calculate the temperature ratio, pressure ratio, density ratio, and area ratio. This coding is to calculate the equation above here, and this coding is to create the table for the result later. After finish doing the coding, then click run to see the result. The result will be appear here at the command window, and to see the table clearly, we need to click table so that the result will be appear here. So let's make it bigger so that we can see the result clearly. So next, I'm going to explain about how to create a table for normal stationary shockwave flow table in this MATLAB software. First, we need a requirement which is Mach number less than 5, and this M1 is represent downstream Mach number, M2 is represent upstream down number. So for the range of downstream Mach number is from 1 until 5, and 0.2 here is represent the increment for the result in normal stationary shockwave table later. So here is the equation in coding form for to calculate the pressure ratio, temperature ratio, density ratio, and Mach number at upstream. So this is coding to calculate all the equation above, and this is the coding to create a table for the result. Finish with the coding, then click run so that the result will appear here at the command window, and click table to see the result clearly here. Make it bigger so that it can display all the result.
You already heard the flow table explanation, so I'm going to explain the GUI flow. As you can see, this is the main interface of our GUI, and we combine isentropic flow and normal stationary shockwave into one GUI. When we click this button, isentropic flow calculator will come out, and when we click this button, normal stationary shockwave calculator will come out. This function A refers to isentropic flow box, and we use callback to call the isentropic flow calculator coding file, and we put the file name under function A to link the calculator coding file with the main interface of GUI. The same steps were used to call the normal stationary shockwave calculator. This is isentropic flow calculator interface of GUI. We put user guide here so the user know how to use this GUI, and this is the parameters that involved in isentropic flow. When we click this Mach number, the isentropic flow calculator Mach number will come out, and the way to do this is the same as main interface we showed you just now. This is the workplace isentropic flow calculator Mach number of GUI, and you can see here Mach number is input and the rest of parameter is output. So how we do this? OK button is used to link the input and output code. To do this, right click the OK button, view callbacks, and click callback, and it will lead you to the code. This coding is used to make Mach number as input and to allow user to insert value of Mach number in this box. These codings are used to calculate all the rest parameters after the map value number is inserted. This is the backbone of GUI. If the equation coding is wrong, the output value will be wrong. To get the rest of the parameters, this code is used to view the parameters output value. As you can see, all this code is under the function of push button 1. How do we know that OK button is push button 1? To know this, double click OK button, and this box will come out, and find tag, and you can see it's written here push button 1. This is where I edit all the title boxes. Before I run the GUI, I want to show you that different boxes has different functions and how to create them. The title boxes, yellow box, and green boxes were created by clicking these static tags. To create input and output boxes, the white boxes, we use this edit tag feature. To create this OK button, push button feature was used. Now I will show you how to run the GUI from A to Z until we get the output value parameters. Now you know how to create GUI. The only thing left is run the GUI and see either the output value is right or wrong. As you can see, the output parameter values is same as the isentropic table values, so your coding is right. As you can see, the output parameters values is same as the table of stationary normal shockwave, so your coding is right. Last but not least, even though we managed to create GUI, we face a problem for isentropic flow calculator where we have a problem with error ratio input parameter coding. For stationary normal shockwave calculator, we face problems for temperature ratio, pressure ratio 2, and pressure ratio 3 input parameter coding. That's all from F-18 Hornet team. Thank you.